Okay. I like, in particular, a comment that Michael Murphy made when he said we were often prisoners of context. Did I get that right? There is a convergence, I think, a convergence of need and a convergence of opportunity. As evidence, well, as an indicator of the need, and I'll go back into it further as I go on. Consider this New York Post headline. Now, they'll abbreviate and so on because they want to make it in big type and all that kind of stuff. ME's largely ignorant about how things are made and work. And they'll quote our Vision 2030 survey of engineering managers. Now, I'm going to talk about, fill you in on how I get to that kind of bit of exclamation. But there is an issue there that at ASME we are determined to tackle. And there is a convergence of need that moves engineering in one direction and engineering technology in another direction closer. The challenge for us in engineering technology is, what do we do best? Can we prove it? Is there a demand? I think you're going to see that the demand is there. I think it can be proven, and we can work on what the best part is. One word of thought, and that is, do not underestimate ever branding. We have unfortunate branding at the moment. I've had unfortunate branding for years. An example of why you don't underestimate branding is over the last 2 weeks, there was a survey publicized where more people are in favor of the Affordable Care Act than are in favor of Obamacare. Yeah. It matters. It really matters. Now, my professor didn't treat me as a freshman. We didn't know anything. We're doing engineering now. Do not underestimate that either. You'll see in a minute where I head with that. I'm talking about mechanical engineering and mechanical engineering technology, and I'm going to go back and forth between the two. There's mechanical engineering. Now, ASEE data. 290 in the US, 296 programs, over 110,000 full-time students. 50% growth in the last 10 years. Largest undergraduate engineering discipline. And we showed that to the ASME Board of Governors, and we say, so what's the problem? It looks pretty good. Well, there are significant problems in there. Beneath those numbers, beneath what's going on. Now, I'm even going to pump those numbers up a bit. That was just full-time. When you get total ME, you get up to 120,000. When you throw MET in there, you get up to 128,000. %. Now, is 6%, going back to that last chart, is that top box on that last chart, is that the flame of the candle that's going to get snuffed out? Or, and I'm going to go off the rails here, I understand, or is that Apple computer compared to the PC market? It all has to do with what is in demand and what we do best. Notice what 12% women means. We've been looking at 12% women for a long time. We've been lamenting 12%, 11% women for a long time, a decade. What that slide right there doesn't tell you is, and I'm going to say it because I'm close enough that I think it's actually true. That 58, that almost 16,000 women is the largest collection of women studying undergraduate engineering in the U.S. Largest. Basically, we've been going back and forth a little bit with civil for the last year. Civil's been at in the 14 to upwards of 15,000 women. With these last data in ASEE, I think the combined, and comparing with the combined civil and civil/environmental engineering at the undergraduate level, I think mechanical has just moved ahead. And we're talking about, for years we were 200 or 300 women behind, and now we're probably 200 or 300 women ahead. But the point is, in all of those, whenever you see the demographics and have that discussion about women in engineering and so on, and you look at engineering, it's 12, 14, whatever it might be. If you keep looking at the percentage, you don't see a percentage times a large number. So then I started looking at these things and I said, wow, there's more women studying mechanical and mechanical engineering technology in the U.S. than there are studying MET to start with. Now I say, okay, MET's got a feeder from associate degree programs and so on and so on. Then I look over and I say, well, ME's got a feeder of associate degree programs also. So, okay, I'll wipe that out as being in the noise. The point here is that unless we do something, it's going to evaporate, or it's going to be special. Which way are we going to have it? Although I think it's an interesting step, I'm a little bit concerned, with all due respect to Ken, that general engineering is a way to make it evaporate. Not make it evaporate, but I think that might be that might be the ultimate the result. You have to worry about the branding, and general is not going to get it for you. General anything is not going to get it for you. So that's a concern. We've heard some things about applied engineering. Well, I thought that's what engineering was. But we are kind of prisoners of context and so on. So, oh yes, all right. There is a heck of a lot more research going on, and you all know the evolutions of the College of Engineering over the last years. So, all right, I'll give a little bit on that, and maybe it is time for applied engineering, although it seems a little funky to me. College of Engineering, world-class publicly funded research, some of the best in the world, very, very, obviously a standard-setting kind of arrangement. And in the public interest, because if we don't have the publicly funded research, what you get is everybody owns the research, and they're not going to tell you what it is unless it's in their best interest to sell it to you. So publicly funded research is hugely important. We don't want to do anything about messing that up. We want to enhance that. But on the other side, we have an issue with practice. And I didn't put a fulcrum in the middle of that because I don't think we should settle for any kind of a notion that it's an either or. We don't need to settle for that. It's both. And what happens is we've got some asymmetric forces here, and we keep arcing towards research and don't have enough force in the other direction to kind of line this thing out. The Vision 2030 project that we undertook at ASME, there you can see it. We got the voices of 1,400 engineering and managers and 1,100 early career engineers. Department heads at 80 ME programs. And as I said, I'm going to be talking about ME and MET back and forth. 15 categories and 16 action items. Now, I keep reading this stuff, and I keep seeing MET all over the place, MET all over the place, and this is a study about engineering graduates. The number one issue, practical experience, how devices are made and work. A majority of engineering managers said this is a problem with fresh graduates. Now, we asked them, we gave them an array of choices. We said, this is a weakness and it needs fixing, needs strengthening. We also gave them choices like this is a weakness and it doesn't need strengthening. In other words, we don't care. And a variety of arrangements in the middle. So what you see in that chart is where the bars are of equal length. It's where you get a pretty strong consensus among the three groups of supervisors in industry and the young engineers and the department heads about their curriculum. Where the bars are of different length, then you get disagreement. It is ordered by industry, that red bar. So number one issue is practical experience, how devices are made and work on a fresh graduate. The second one is communication skills. The third, engineering codes and standards, overall systems perspective, problem solving, critical thinking, design product creation, and it goes on down. The agreements are there. Everybody thinks something needs to be done about these areas. The managers, the young engineers about their own preparation, and the department heads. Over here, there's disagreement. There are two very interesting ones in there. The communication skills. The managers say, we don't think this is very good. The early career engineers think we communicate great. and the department heads say, well, our curriculum is fine. It gets even a little more funky down there around new technical fundamentals, bio-nano, the third bar from the bottom, if this works, which it doesn't. Out in there, where the young engineers are interested in learning, they should learn more about bio and nano and these other technologies. The department heads say, the longest blue bar, our curriculum really needs to reflect more of this, and the engineering managers, the red bar, say, I don't care about your bio, nano, advanced technology someday in the future. I really don't care. I need something now and fairly soon to now. As a result of this work, and there's a lot behind it, that is obtainable on that goasme.org v2030, which is presentations, executive summary, and the full report. That has adjusted the strategy for ASME education and the kinds of things that we've been concerned about and look at. As a result of that work, the leaders, the co-leaders of the team that developed the project, Scott Danielson, Alan Kirkpatrick, Bob Warrington, are getting the Ben Sparks Medal this year. Ben Sparks was an engineering technology faculty member at what was once called Southern Tech in Marietta, Georgia. Those three guys, one at an institution who was running engineering technology at the institution, the other at an institution with no engineering technology, and the third at an institution with both. The action items, richer practice-based engineering experience for students. And we would say from day one, going back to that first slide where she said, we're engineering now. They came to engineer. We pushed them through a math, science, death march. They came to engineer. And a new balance of faculty skills and experience. And for the moment now, since I won't go through the others, but it's there. Increased familiarity with how devices are made and work, design, build throughout the curriculum, throughout the degree program. I'm saying that about engineering. I think you need to ask yourselves, does that happen in engineering technology as well? Throughout, up and down, 4 years. More exposure to engineering codes and standards. In the ABET criteria for engineering technology, it used to be fairly explicit. It is now not so. That's a little bit of a disappointment. That we might want to think about doing something about. On the subject of capstone design, both engineering and engineering technology have it. This is a little snapshot study of ME. The majority of the design projects that students were doing were corporate sponsor, corporate problem. A bit on design competitions, independent research, innovation kind of studies, and developing world. This was done, I think, this was done in 2009. I think the developing world humanitarian box is probably bigger now and not just 4%. That's my hunch. But the important part is that how much industry is there. When we go to China, when we go to ASME and ASME education, to Latin America, when we go to India, we don't see that. That's a strength. We see a much more classical education. We don't see a lot of engineering experience, engineering practice experience on the faculty aggregate. That's an advantage. I mentioned that you saw the enrollment statistics. Now, the number of faculty slots has not by any chance kept pace with that. So there is another convergence of good news. More and more, and we're going to do some research on this to find out where that baseline is. There is an increasing use in mechanical engineering for what, in the best sense, I think, and in some institutions, it's called professors of practice. This is a page out of the medical school. Rather than sitting back and having physician envy, as we often do with engineering, borrow that page out of the medical school increasingly. These are not tenure-track positions. They could be if one redefined it, but they don't necessarily need to be tenure-track positions. These are PhD engineers from industry, 10, 15, 20, 30 years experience, full-time on engineering, in mechanical engineering departments, teaching the design sequence. That's the strength. Gee, where are the other professors of practice? There's a whole room full of professors of practice sitting right in front of me right now that nobody thinks of that way. Not enough to. Whether it's clinical professor, whether it's something else. There needs to be an infusion, if we're going to have more design and build in the engineering curriculum, somebody to teach it. When you have positions like this, you have that person in the department or those people in the department who are the department's effective liaisons with industry for not only that, but applied research. I would encourage you to think about these things, and ASME is going to be thinking about how to advocate these things. Now, what's the risk? Well, let me put it this way. How do these things come about? You saw that there was an asymmetric forces in research funding and not so much practice funding. The clue I got in the best sense for how to work this, the ideal sense for how to work this is actually practiced by Cornell. Their design program in ME extends all 4 years. Their design build extends all 4 years. They sometimes have trouble with the ME evaluator in the ABET process because the person's looking for the senior design and says, where's this? And they say, that was done when they were sophomores. That was done when they were juniors in this course. So it takes a little explanation. Well, how'd you get the position? Well, I got two. How'd you get them? They're endowed by industry. Where's those resources going to come from? They are endowed by industry. They are endowed in such a way that they are practice positions. They are not research positions. The business model of the institution is built on and has been built on those research positions. And you can't just say, well, don't do that anymore. You need to add this other thing on that says more resources, more infusion of resources, and a curriculum to match. But it's not coming from the government, it's coming from industry. And it's durable because it's endowed. Now there are variations in other ways to help faculty be more practice-oriented and so on in the traditional engineering program. But that's sort of the gold standard idea, make that happen. And I'm talking, when I say make that happen, I'm talking to our folks in ASME and saying, and to our industrial advisory board. And ASME with 100,000 members in industry and so on, how do we make this happen? And that's some of the challenges that we're trying to work through. Now, on student front, and I'll try to wrap this up quick. We used to have an old brochure. Seems redundant. We had an old brochure that was mechanical engineering technology, which path will you choose? False, forced choice, just in the rhetoric, in the language, in the whole thing. They are now, and have been for some years, pathways to engineering careers, pathways to mechanical engineering. What is a mechanical engineer? These are about both approaches in mechanical engineering and mechanical engineering technology, leading to the mechanical engineering world. Oops, sorry. We said, okay, let's stop the arguing around the table and let's finally tell the public the main ways that you can do this because the public has no idea. And we simplified it for the brochure and so on. But the diversity of this way of approach, I mean, on one hand we say, oh, this is a mess, and on the other hand we say these are ports of opportunity for, depending on your circumstances, where you are, what you can get access to, and so on. There are ways for you to become an engineer. There are ways for you to become a mechanical engineer that are not just one way. We took what is in our discipline a sort of a pie chart that we used for years and tried to find another way to go about it. And trying to explain to students, guidance counselors, and the public, how does this mechanical engineering technology and engineering education kind of work? But I will read what it says, even though you can see it there. Both ME and MET graduates can move from their respective disciplines into product and design and development, production, project management, sales, customer support positions, and supervision or management. ME graduates have the additional preparation to move in research and sophisticated technical analysis positions. In both cases, career progression is more a function of the individual's motivation, dedication, personal skills, and abilities than the bachelor's degree they earned. That's what the brochure says. Now, another thing I will put out is the issue of licensure. And we in ASME regard licensure to be entirely about public safety. It is not about the definition of the engineering profession. It's state by state by state, and the state's interest in licensure, in our view, is limited to the safety of the public, not anything else. When you look at public safety, you see the combination of things that make for public safety. Why is this not a big issue, except in the circles that we talk in? It's not a big issue nationally. Why is that not a problem? You know, it's not a problem because this system works. Of ABET accreditation, industry codes and standards that are backed up by law, and that's most, between those two, you cover most of engineering that happens. And then for independent private practice and public works kind of projects, you get PE registration and you get the other piece. But all three of those are what makes for public safety. It is not the domain of any one particular one of those. So as a bit of a wrap up on this piece, technologist, that word technologist does not exist in ASME or significantly in industry. We regard the BS as the first professional degree. Basically banging onto that, those are the societies that have so far signed on to the position paper that the next slide reflects. And the licensingthatworks.org website. Because this is a state by state by state thing. Our issue is we don't know, we don't have offices in every state. So if something's happening in your state, to do something such as change the requirements for PE licensure either away from technology, not excluding it, or to raise that, that academic standard to a master's degree, which does engineering technology no good, and we're concerned is not based on a remedy for public service problems, public safety, let us know. Because the only way, and we will go into that state, we will go to that state board, we will go to that legislature when we find out something is happening, and we will defend this position. Because that combination is so effective in the US for public safety, the legislature doesn't see an issue. Frankly, and we've seen it, if that legislator sees an opposition, they're going to walk away. They'll just walk away. They don't need a hassle on this because it's not a significant enough problem in current society and is not, the evidence is not there to project that it's going to be a significant enough problem in the future. When was the last time you ever heard somebody say, I'm going to fix an issue that we have a quality issue, we have a malpractice issue over 35 years of an engineering career, we're going to fix it with a master's degree? We're going to fix a problem in the field with a master's degree. Nobody says that. Doesn't happen. Okay. So, ASME supports, look, if you've got 2 valid and reliable examinations, and NCEES's core business is valid, reliable, field valid, reliable examinations. Good. You've got 4 years of supervised practice under a PE. That should mean something. That PE should be on the hook for something. And a sufficient demonstration of continuing education over the course of a 30-year career. If you have a problem in the field, fix it there. Don't fix it on the front end. Don't think you're going to fix it on the front end. Anyway, that's our position on PE licensure and the Master's as First Professional Degree. Unfortunately, I'd like to think that we were honorably defeated in the halls in the discussions in ABET when master's level accreditation came up as a possibility. Actually, unfortunately, I think we might have been asleep at the switch and it just kind of happened and whoops, what happened here? Because that's a piece of the puzzle as well. And the ultimate goal I would submit to you on this front is PE registration from an ABET accredited master's degree program. Fast forward 10 years, 15 years. We don't think that's a good idea. There's the email, the brochures, the website, any documents that you might find useful in your enterprises and so on, please let me know.